In this lesson, we're going to talk about the ways you can prove that a quadrilateral is a parallelogram. So we have a few theorems that we're going to go over, but you can show that a quadrilateral is a parallelogram if you can show one of the following theorems to be true. So the first one we have is if you can prove both pairs of the opposite sides are going to be congruent on a quadrilateral, then you can say that it's a parallelogram. Another theorem is if both pairs of opposite angles of that quadrilateral is congruent, then that quadrilateral is a parallelogram. If the diagonals of the quadrilateral bisect each other, so they cut each other in half, then the quadrilateral is a parallelogram. Another theorem is if one pair of opposite sides of a quadrilateral are both parallel and congruent, then you can prove it's a parallelogram. And our last one, if an angle of a quadrilateral is supplementary to both of its consecutive angles, then it is a parallelogram. Right? So those are the 5 ways, as well as obviously using your definition of a parallelogram, which is just that both pairs of opposite sides are going to be parallel to each other. So let's look at the first section of our problems. Okay, they have us determining if each quadrilateral is a parallelogram. And then if so, we're going to justify our answer. And if not, obviously stating why it's not as well. So in the first picture here, we can see that they have given us 2 pairs of opposite sides are going to be congruent. So therefore, we can use one of those theorems we stated above to say that yes, this is a parallelogram. And to justify, we can say both pairs of opposite sides are congruent. Okay, we do need to specify that it is both pairs of opposite sides that are congruent and not just opposite sides are congruent. Okay, and our next one, number 2, we are given these angles here are congruent as well as over here. All right, so remember when you're given congruent angles, you can use your alternate interior, alternate exterior, or corresponding angles, converse theorem to prove that the lines could be parallel. But let's look and see what lines we would be able to prove parallel using those angles. So I'm going to start off by highlighting my 40-degree angles. Okay, so when I look at that, I can see that the line they share, remember that's your transversal, and the other 2 lines are going to be the lines that would be parallel to each other. So that's going to be the top and the bottom. Then when I look at the other congruent angles, okay, so my 30-degree angles here and here, once again, that line in common is your transversal. And then the other 2 lines you have highlighted are going to be your parallel lines. Sorry, I was blanking. So if I look at that, I can see that the lines that they do not share are going to be the top and the bottom once again. And therefore, I've only been able to prove that one pair of opposite sides are going to be parallel. Now, something we can also kind of look at as well, and this does kind of help us out sometimes, but in this case it won't, but mentioning that you could use your congruent triangles. If you can prove 2 triangles congruent, you can use that CPCTC to say other sides, other angles would be congruent as well. In this problem here, I'm not going to be able to prove my triangles to be congruent because I have no congruent sides. I'm only going to be able to come up with congruent angles, which is going to be a similar triangles, not a congruent triangles. So my answer here is going to be no. And I can say both pairs of opposite sides are not proven to be parallel. All right, so moving on to our last one for this section, we have number 3. So looking at number 3 here, we do currently have our congruent sides that are given. So we have a few options. We could prove both pairs of opposite sides are congruent. So maybe we can look to see if the top and the bottom can be proven, which no, they cannot, because we don't have enough information to come up with that. But I could also prove one pair of opposite sides to be congruent and parallel. And right now I have the congruency. I just need to see, can I prove them parallel? So if we look at the angles that we're given here, we're given that 110 degrees and 70 degrees down here. Well, that will be supplementary. That will be adding up to 180 degrees, which could prove my consecutive angles to be supplementary. But when I look at it, the lines that they do not share would be this top and this bottom side of the parallelogram, which those would be the ones I could prove to be parallel. And they don't happen to lie on the congruent sides that I was given. So I'm not able to prove one pair of opposite sides to be both congruent and parallel. So my answer is going to be no, and I can use that as my reason. All right. So that's it for that section. Now let's look at these bottom 2 problems, our last 2. We're asked to determine whether the quadrilateral ABCD with the vertices is a parallelogram, and then we're going to justify our answer based off what we use to prove it. All right, so I'm going to zoom in, and we kind of talked about this in the previous lesson, but remember, we have a few different ways we can do this. In the last lesson, last notes, I was proving that the diagonals bisected each other by using my midpoint formula. So I've done that example already. I'm going to try in these 2 here doing another way. And it will just kind of be up to you, unless I mentioned earlier in the previous video that I might specify. So you'd still want to be familiar with using all of my formulas. But if they don't specify that, you can use whichever way, whichever method you want to prove that it's a parallelogram. So we've done the midpoint. Now we could also talk about how both pairs of opposite sides are going to be parallel. And so that's what I'm going to do here. I'm going to just real quickly draw just so I have an idea. We've got a parallelogram here. Remember, it doesn't have to be exact. I'm just going to draw an idea. We've got A, B, C, D. All right. And I want to prove using my slope formula that AD is parallel to BC and AB to be parallel to DC. So that's what we're going to do. So let's start off with our AD. So remember your slope formula we have is going to be the difference in my y coordinates over the difference in my x's. So for A and D, I'm going to have 5 minus -1, which will be a +1, and then 2 minus 3. Okay, so 5 plus 1 gives me 6. 2 minus 3 is going to give me -1, and therefore I have a slope of -6 for AD. Now let's check our BC. Okay, so focusing in on BC, the difference in my y's will have 9 minus 3, and then 5 minus 6. Okay, so 9 minus 3 is going to give me 6. And then 5 minus 6 gives me -1. When I simplify, I'm just going to get -6 for that. So we currently have AD to be parallel to BC since they have the same slope. Now let's check out our AB. Okay, so the slope of AB, we are going to have, let me scroll up a little bit, 5 minus 9. And then we will have 2 minus 5. Okay, so 5 minus 9 is going to give me -4. And then 2 minus 5 gives me -3. So we get a slope of +4/3 since we have a negative divided by a negative. Then let's see if we get that same slope for BC. Sorry, not BC, DC. All right, so difference in my y's is going to give me 3 minus -1, so +1. And then 6 minus 3. 3 plus 1 is going to give me 4. And then that 6 minus 3 gives me 3. So here I have that same 4/3 as my slope. And therefore I have proven that both pairs of opposite sides are going to be parallel. So we can say yes. And both pairs of opposite sides are parallel. Okay? So it's another way that you can do this. Now let's look at number 5, and we will try another one. I'm going to kind of keep it similar, but still using a different one to prove it. So once again, just going to start off by drawing a quick visual. Okay, so another way we could do this is, remember we have the theorem that stated we could prove one pair of opposite sides to be both congruent and parallel. So for example here, what I can do is I can prove AB is parallel to DC, and I can then use my distance formula to prove that AB would be congruent to DC. So let's do that. We've got AB, okay? So for AB, we have the difference in my y's, so 6 minus -3, so +3, and then -1 minus 2. Okay, so 6 plus 3 is going to give me 9. 1 minus 2 is going to give me -3. And so I'm going to have a slope of -3. Then let's check out DC. Okay, so for DC, we can do 9 minus 0, and then 2 minus 5. So 9 minus 0 gives me 9. 2 minus 5 is going to give me a negative 3. And so I have proven that AB and DC are going to be parallel. Now I need to prove that they are congruent using my distance formula. Okay, so we're going to plug into the distance formula here. We have the square root of, and then in parentheses, I'm going to do the difference of my x's. So we'll have negative 1 minus 2 squared plus then the difference of my y's, so 6 minus negative 3, which will give me plus 3 squared. Okay, so negative 1 minus 2 gives me negative 3 squared plus then 6 plus 3 gives me 9 squared. Okay, so negative 3 squared gives me 9 plus that 9 squared gives me 81. And so I'm going to have the square root of 90. And I'm going to, just for the sake of it, make sure we can practice simplifying. So some factors are going to be 9 and 10. And I notice here that we got that 9, which is a perfect square. So I'm going to pull out a 3. And then my 10 here, my factors are 2 and 5. I don't have another pair, so I'm going to leave it as 3 root 10. Now let's check out, we've got DC. Okay, so for DC, we can do 5 minus 2 squared plus that 0 minus 9 squared. We'll get 5 minus 2 gives me 3 squared. Plus, and then we've got 0 minus 9 gives me negative 9 squared. And so when I expand this out, I'm going to get 9 plus that 81, which will give me that square root of 90 again, which we said is just going to then be equal to 3 root 10. So we have proven that AB and DC are both parallel and congruent. And so we can prove that, yes, this is a parallelogram. We've got one pair of opposite sides are both congruent and parallel. All right, so that is it for our lesson on how you can prove a quadrilateral to be a parallelogram using those theorems, or even, as I mentioned earlier, you can use the definition of a parallelogram.